are going to discuss the question from signals and systems given in GATE 2004 from the LTI systems, finding the stability. So here a causal LTI system is described by the difference equation 2y of n equals to alpha y of n minus 2 minus 2 x of n plus beta x of n minus 1. The system is stable if, only if, we need to find the alpha and beta values for becoming the given difference equation describing the system is stable. So now we'll see the solution for this. Come into the solution. Given the difference equation 2 into y of n equals to alpha y of n minus 2 minus 2 x of n plus beta x of n minus 1. So that's what given. So here we will find the solution by applying the Z transforms. So apply Z transform for this, then we will get 2 y of z equals to alpha. We know that by applying the time shifting property, this is z power minus 2 y of z minus 2 x of z plus beta. Here also time shifting property, this is z power minus 1 into x of z. Taking all the y of z terms one side and x of z terms of another side, it becomes y of z of 2 minus alpha z power minus 2 equals to, taking the x of z as common, it becomes beta z power minus 1 minus 2. Then finding the transfer function of the system, h of z equals to y of z by x of z, that is equals to beta z power minus 1 minus 2 divided by 2 minus alpha z power minus 2. So here converting in terms of positive powers of z, taking the z power minus 1 as common here, then it becomes beta minus 2z divided by, taking the z power minus 2 as common here, this becomes 2z square minus alpha. Then 1z will cancel, then taking to the numerator, this is z into beta minus 2z divided by 2z square minus alpha. Take the 2 common in both numerator and denominator, then becomes the h of z equals to z of beta by 2 minus z divided by z square minus alpha by 2. So this is the transfer function we got here. So finally we got that h of z equals to z of, and we have z also here. We have z na, okay, z into beta by 2 minus z into beta by 2 minus z divided by z square minus alpha by 2. That's what the transfer function we got here. Now we need to verify that the system is stable. Given that the system is stable, the system is stable, then we need to observe the values of alpha and beta for becoming the system stable. So in order to become the system stable, so to become the system stable here, the poles and zeros, from the poles and zeros, so here to become the system stable, always the poles must be lies within the unit circle. So for system stable, the poles always lies within the unit circle on the jet plane. We know that. So based on this condition here, by finding the poles here, coming to the poles, that is making the denominator equals to 0, z square minus alpha by 2 equals to 0, then z square equals to alpha by 2, then z equals to plus or minus square root of alpha by 2, then this value must be less than 1. So then observing that the magnitude of square root of alpha by 2 must be less than 1, then applying the square on both the side, then it becomes alpha by 2 less than 1, then it is alpha less than 2 here. So we got the condition alpha less than 2. So the poles, taking the condition the poles lies within the unit circle, we got the condition alpha less than 2, that is one condition. And coming to the zeros here, zeros, so we have will obtain by making the numerator term equals to 0, that is z equals to 0 and beta by 2 minus z equals to 0, then z equals to beta by 2, and here we have two zeros, that is we have two zeros, that is z equals to 0 and beta by 2. So for the stability of the system, the transfer function does not depend on the zeros, so it depends only on the poles of the system, it does not depend on the zeros. So we can consider that beta may be any value for becoming the system stable, but alpha must be less than 2. So we got the beta must be any value and alpha we can consider only less than 2 by observing the options here. So the mod alpha must be less than 2 and any value of beta we can consider. So that's what the answer we got here. So this is mod alpha only, this is mod alpha, this is mod alpha by 2 less than 1. So we got mod alpha less than 2 and the beta value we can consider it as any value. So the option C is correct here. So that is the answer.